And we've talked about quantum numbers being related to energy. So you can see here that energy and sublevels are what it's all about. But right over here, energy increases. It's all about energy. Now, in this particular example, we're using energy level 4. The energy level is the first quantum number, so designated by n. In this case, n equals 4. It is the fourth row on the periodic table. I picked this one because it shows all 4 sublevels that are possible. As we've said, the energy level will also determine the number of sublevels, sublevel being the second quantum number. So here you have the energy level, first quantum number, and you have the sublevels, which is the second quantum number. And we always start with the lowest rank, that's S. So this would be 4S because it's the fourth energy level and it's a sublevel S. 4P, fourth energy level, P sublevel. 4D, fourth energy level, D sublevel. 4F being the fourth energy level and the F sublevel. Let's look at energy level 3 and 4 put together. Notice energy level 3, n equals 3, meaning it should have 3 sublevels. So you have 3S, 3P, and notice 3D. These are in the green. And there's energy level 4 with 4S, 4P, 4D, and 4F. Notice there's an overlap here. In general, S is always lower than P, but that's all within the same energy level. But you notice that 4S is actually lower energy than 3D. It really helps if you think in terms of all these as a staircase. It's just climbing stairs or climbing a ladder. It's all by energy. So again, you see another look at the first 2 quantum numbers. If we put 3 of the 4 quantum numbers together, we get something that might look like this. We have the principal quantum number, the n, that's the energy level or the rows on the periodic table. Then you have the sublevels for each energy level. So 1s, for energy level 2, you have 2s and 2p. Energy level 3, we have 3s, 3p, 3d. Energy level 4, we have 4s, 4p, 4d, 4f. But then we can go to the third quantum number, which are the orbitals. Remember that each sublevel can be subdivided into orbitals. The s sublevel always has 1 orbital. The p sublevel has 3 orbitals. The d sublevel has 5 orbitals, and the f sublevel has 7 orbitals. So you can see that here. Energy level 1, 1 sublevel, the 1s, and also 1 orbital. Can contain up to 2 electrons. Energy level 2, we have 2 sublevels, 2s, 2p. The s has 1 orbital, and the p has up to 3 orbitals. And again, each can contain 2 electrons. Energy level 3, 3s, 3p, 3d. The s has 1 orbital, the p has 3 orbitals, d has 5 orbitals, and each can contain up to 2 electrons. And then 4s, 1, the p can have up to 3, d can have up to 5, 4d sublevel has 5 orbitals, and 4f can have up to 7 orbitals, each with 2 electrons. This picture shows us a little bit more development of what we just did. And again, what you'll see is kind of like a ladder of the energy levels. Energy level being the first quantum number. There are 7 rows on the periodic table, so you can see here are the 7 major rows representing the rows on the periodic table, the energy levels. Then we subdivide the energy level into sublevels, S, P, D, and F, depending on the energy level. Energy level 1 has S, energy level 2 has S and P, energy level 3 has S, P, and D, energy level 4 has S, P, D, and F, energy level 5, S, P, D, and F, and so forth. Then we have the number of orbitals shown here. S has 1 orbital, 2s also 1, 2p has 3 orbitals, see, 3p. The 3d has 5 orbitals, 4d, and then 4f has 7 orbitals. So similar kind of thing. Then over here on the side, you can see we put in the amount of electrons that might be available on that whole energy level. Here, since there's only 1 sublevel, it's the first energy level, quantum number 1. Sublevels, quantum number 2. There's 1 orbital, quantum number 3. And there's up to 2 electrons, which would have opposite spin. So if we showed the spin, that would be quantum number 4. If you look at energy level 2, we have 2 sublevels. So 2 is the first quantum number. The sublevels, S and P, are the second quantum number. here are the orbitals, 1 orbital for s, 3 for p, that's the third quantum number. And then if you put 2 electrons in each and they have opposite spin, you'd have 8 total electrons in that energy level. Energy level 3 is a little more difficult now because you see you're taking a staircase, but 4 sneaks in there beforehand. But if we only consider energy level 3, you can see here the 3s and the 3p would give you 8, and then you get 10 more here. So it's actually 18 altogether. It gets a little more complicated because these energy levels start to interrupt with each other.